All of you welcome in the BSc Part 1, Sem 1. We will study Mathematics Paper 1, Differential and Integral Calculus, which is of 60 marks and 15 marks for assignment, total 75 marks. There are two papers of mathematics, Paper 1, Paper 2, each of 75 marks. Myself, Dr. D.N. Varade, we will study this Paper 1, Differential and Integral Calculus. First we see the brief idea of the syllabus. The syllabus contains 4 units. Unit 1 contains limits, continuity and derivability. Unit 2 contains mean value theorems. Unit 3 contains indeterminate forms and beta gamma functions. And unit 4 contains double integration. These are the 4 units. Textbooks. The textbook for the paper is Differential and Integral Calculus by Dr. T.M. Karade and others by Sonanelu Publication, Nagpur. Now we start Unit 1, Limits, Continuity and Derivability. You know the idea about limit, continuity and derivative in your previous class, 12th class. First we see the definition of the derivative, or we can say the definition of derivability of the function. Definition: derivability of the function f of x. You know the definition of derivative, you have seen in the 12th class. It is the limit. If the limit exists, then we say that it is the derivative of the function at that point x0, limit h tending to 0, f of x plus h minus f of x divided by h. If the limit exists, then we say that it is called as derivative. We see the definition. Let f of x be real value, f of x be real valued function defined on an interval I, then f of x is said to be derivable, at any point x0 belongs to open interval AB if limit h tending to 0, f of x0 plus h minus f of x divided by h, or secondly we can write the second limit x tending to x0, f of x minus f of x0 divided by x minus x0, if this limit exists. Now these are the two definitions. This is the first definition, this is the second definition. Now it is called as f dash of x0, derivative of f at the point x0. It is also f dash of x0. This limit is called derivative of differential coefficient. Derivative of differential coefficient of f of x at point x0. And you know the derivative is denoted by f dash of x0, or it is also denoted by df by dx at the point x0. The derivative of f of x at point x0 belongs to AB is denoted by f dash of x0 or df by dx at x0. Therefore, from the equation 1, we say that f dash of x0 equal to this limit, or f dash of x0 equal to second limit. Therefore, from equation 1, we write, therefore equation 1 implies f dash of x0 equal to limit h tending to 0, f of x0 plus h minus f of x0 divided by h, or f dash of x0 equal to limit x tending to x0, f of x minus f of x0 divided by x minus x0 if the limits exist. Now this is about the definition of the derivative. First definition, second definition. Then we see the right hand derivative and left hand derivative. You know about the right hand derivative, left hand derivative. You have seen. You see the definition of right hand derivative and left hand derivative. Right hand and left hand derivative of the function f of x. You know the number line, there is 0, and from 0 onwards there is 1, 2, 3, 4. Therefore, this will say that h tending to 0 plus, and in the left hand side of the number line, we can say that s tending to 0 minus in the left hand side of the number line, and it is on the right hand side of the number line. The right hand derivative of f of x at the point x0 is defined as f dash of x0, if this is right hand, we write here plus, f dash of x0 plus equal to limit h tending to 0 plus f of x0 plus h minus f of x0 divided by h, or f dash of x0 plus equal to limit x tending to x0, f of x minus f of x0 divided by x minus x0. These are the two definitions if the limit exists. If the limits exist, then we say that this is right hand derivative is also right hand derivative at the point x0. Similarly, you can write the left hand derivative of the function. Similarly, left hand derivative of f of x at x0 is given by now you can write here f dash of x0 minus, here also s tending to 0 minus. Similarly, the second definition, you can take here f dash of x0 minus and this x tending to x0 minus if the limit exists. Now this is about the right hand derivative and left hand derivative of the function f of x at the point x0. Then we take some example so that the idea of the right hand and left hand derivative gets clear. Example, find the right hand and left hand derivative of the function f of x equal to mod x at the point x equal to 0. Therefore, here we have to use the right hand derivative and left hand derivative definitions. Solution. Right hand derivative of f of x is f dash of x0 plus equal to limit h tending to 0 plus, where is the definition? Second one, limit x tending to x0 plus f of x minus f of x0 divided by x minus x0. Now here we have to take the derivative at the point x equal to 0. Therefore here x dash x0 equal to 0. Therefore we write f dash of 0 plus equal to limit x tending to 0 plus f of x minus f of x0 divided by x minus x0. Now we see the definition of the given function. Equation 1, f of x equal to mod x. You know mod x for the greater values. If x is greater than 0, mean the right hand derivative f dash of 0 plus. For x is greater than 0 means right hand derivative. For the right hand values, you know mod of x equal to x. And for the left hand values, we know mod of x equal to minus x. Mod of x equal to x for x greater than 0 and mod of x equal to minus x for x is negative. Now I put the value of the function by equation 1. Therefore, limit x tending to 0 plus mod of x minus mod of 0 divided by x minus 0. Therefore, limit x tending to 0 plus, for positive value we have mod of x equal to x divided by x, and the ratio of x by x we get 1, and limit of constant we know that it is the same, limit of constant equal constant, therefore limit of 1 equal to we get 1. Therefore f dash of x0, f dash of x, f dash of 0 plus equal to 1. Now this is the right hand derivative, we find the left hand derivative by definition of left hand derivative. We have f dash of 0 minus equal to limit x tending to x0 minus f of x minus f of x0 divided by x minus x0. Now take the point x equal to 0, therefore we have f dash of 0 minus left hand derivative limit x tending to 0 minus, now by definition by equation 1, this is equation 2 not 1, equation 1 is the definition of the function, therefore by equation 1 we have mod of x minus 0 divided by, here x equal to 0 in the definition, this is the definition equation 1, x equal to 0, x equal to x, therefore mod of x minus mod of 0 divided by x minus 0, seen by definition of function 1. Limit x tending to x 0 minus mod of x for negative value we have minus x divided by x, therefore we get the value of this as minus 1, and limit of constant is constant, therefore we get f dash of 0 minus equal to minus 1. Now from equation 2 and 3 we can combine the two derivatives. From equations 1 and 2, f dash of 0 plus equal to 1 and f dash of 0 minus equal to minus 1. That is the right hand derivative and left hand derivative are not equal, they are different. Therefore f dash of 0 plus is not equal to f dash of 0 minus. That is right hand derivative is not equal to left hand derivative. That is right hand derivative is not equal to left hand derivative. Now if this is not equal, then we say that the function f of x equal to mod x is not derivable. Hence f of x equal to mod x is not derivable. At the point x equal to 0. If the condition is satisfied, if the right hand derivative equal to left hand derivative, then the given function is differentiable at that point. Then we see definition of the derivative in an interval. Now there are two intervals, open interval AB, closed interval AB. is open interval AB denoted by x lies between A and B, and the second closed interval is denoted by x lies between A and B. Now I have to define the derivative in an interval I. If this is taken in closed interval I, if we take the closed interval AB, then the function is said to be derivable in an interval I if it is differentiable at all the points of the interval AB. And again there is definition, second definition that we see later on.